Good afternoon, everyone. Welcome to the annual technical review workshop for the SONGS San Dieguito Wetland Mitigation Project. My name is Lori Coteen, and I am a senior ecologist for the Coastal Commission. Before I turn this workshop over to the speakers, Drs. Stephen Schroeder, Mark Page, Kat Beheshti, and Sital Prabhu, I wanted to go over a few logistical items related to the Zoom platform and describe how we will run the webinar. Also, please hold your questions for our speakers until the end of the presentations. First, even though we're all getting more familiar with Zoom, I'll give a few Zoom tips. If you'd like to go back and view portions of this webinar at a later date, we are recording it and we'll post the recording to the UCSB SONGS mitigation website in the near future. Everyone attending the webinar has been muted and will remain muted during the presentations, and video has been disabled for all attendees. When it comes to the question period, if you have questions for the team, there will be two ways to ask your question. First, you can type a question into the Q&A box at the bottom of your Zoom screen at any time. When we come to the question and answer portion of the webinar, the team will walk through the questions as time allows and answer them verbally. Second, when we come to the question and answer portion of the webinar, you can use the raise your hand function, also at the bottom of your Zoom screen, to indicate that you would like to ask a question. I will then ask you to unmute yourself one at a time to ask your question. If we are not able to get to all the written questions, our team will try to put together brief written responses to be sent out after the webinar. If you're not able to ask your question during the webinar, please reach out to one of our team members via phone or email with your questions, and we will respond to you directly. With that, I will hand it over to Stephen Schroeder.
So here's the agenda for the presentations today. I'm going to give a brief introduction and overview. Following this introduction overview, Dr. Kat Beheshti will talk about the performance of the San Dieguito Wetlands Restoration Project. Following Dr. Beheshti will be Dr. Mark Page, who is going to discuss salt marsh vegetation biological standards. After Mark's talk, Dr. Sital Prabhu, the project manager for San Dieguito Lagoon for the Southern California Edison, will discuss SCE's planting program. After Sital's talk, there will be a chance for a general discussion. We would like to acknowledge our scientific staff that collect and analyze the monitoring data used to evaluate the performance of the wetland and the reef mitigation projects. We would also like to acknowledge our SAP or Science Advisory Panel, Drs. Rich Ambrose at UCLA, Pete Raimondi of UC Santa Cruz, and Dr. Russ Schmidt at UC Santa Barbara, who we meet with on a regular basis and who provide us with advice on the monitoring program. Some background is important for understanding the purpose and rationale for the SONGS Wetland Mitigation Project. The wetland mitigation is linked to the adverse effects of the SONGS cooling water system. SONGS units 2 and 3 were cooled by a single pass seawater system. Units 2 and 3 have separate intake lines that are located about 30 feet in about 30 feet of water offshore of the power plant. This water is heated up inside of the power plant to about 19 degrees Fahrenheit above ambient. And the heated water and the turbulence in the cooling system kills fish eggs, larvae, and small immature fish. This results in substantial losses that were projected to near shore marine fish in the Southern California Bight. Construction of units 2 and 3 was found to be consistent with the Coastal Act only if these significant adverse impacts to fish would be mitigated. The California Coastal Act requires mitigation of impacts to the marine environment. As mitigation for the impacts to larval and juvenile fish caused by SONGS, the California Coastal Commission required two things of SCE: to create or substantially restore a minimum of 150 acres of wetlands, excluding buffer zones and upland transition areas, and to provide funding for scientific oversight of the restoration project that is independent of Southern California Edison. Key elements of the SONGS Wetland Mitigation Project include out-of-kind compensation for in-plant losses of larval and juvenile fish caused by the operation of SONGS Units 2 and 3. And physical and biological standards were established to evaluate the performance of the wetland restoration project. 1 year of mitigation credit is given for each year that the San Dieguito Wetlands Restoration Project meets the performance standards. Fulfillment of the SONGS wetland mitigation requirement will occur when the number of years of mitigation credit accrued by the San Dieguito Wetlands Restoration Project equals the total years of operation of SONGS Units 2 and 3, which has been determined by the Coastal Commission to be 32 years. Okay, this map shows the location of SONGS. You can see in the red triangle the impact site where the San Dieguito Lagoon site in the green square, and 3 wetlands that are used as reference sites to evaluate the performance of the restoration project. These restoration sites include Carpinteria's Salt Marsh near Santa Barbara, Magoo Lagoon a bit south, and the Tijuana estuary that is south of the San Dieguito Lagoon. Okay, this slide shows a satellite view of the project site before excavation and grading occurred. And you can see in this aerial photograph the San Dieguito River that runs right through it, the I-5 freeway going north to south, the Del Mar racetrack. And you can see that the site consists of ruderal or weedy uplands, old agricultural fields, and a World War II airfield. And then you can also see near the bottom a site that was constructed in the late 70s, early 80s, termed the Fish and Game Basin. This aerial photograph was taken in 2016. Following the construction and grading. During construction, the ruderal areas and the old agricultural fields were excavated and graded to create the planned intertidal and subtidal wetland habitats of the restoration project, also the World War II airfield, which is now a subtidal basin.
Well, listen.
In addition, you can see nesting sites that are not part of the mitigation requirement.
Shorter. You can see.
Who got a top?
Hello? You can hear me okay? I heard something in the background. In addition, you can see nesting sites that are not part of the mitigation project and upland disposal sites that received the majority of about 2.2 million cubic yards of material that were excavated during the construction. You can also see berms that received some of the excavated material. And I said the nesting sites. Nesting sites were part of a restoration requirement for the 22nd Ag District, but are not part of our project, and we do not monitor these. Here's a timeline for the project. The construction started in September of 2006. All modules were essentially completed in November of 2010. There was additional excavation on the so-called Grand Avenue, you can see in the lower left, in February of 2011. And in 2014, in March of 2014, regrading of the W2, W3 module was completed. There's been extensive planting. There was early planting done in 2008, 2009, experimental cordgrass planting in 2011, and extensive planting of both cordgrass and salt marsh plants from 2016 to 2022. Inlet dredging is an integral part of this project. The project requires perpetual inlet maintenance. The initial inlet dredging occurred in September of 2011 and subsequently at about 2-year intervals in November to December of 2015, 2017, and 2019. There is inlet maintenance activity. There was an inlet maintenance activity scheduled for this year that was put off because of the oil spill. Performance monitoring began in January of 2012, and the reports today cover the 10 years of performance monitoring from 2012 through 2021. Okay, monitoring of wetland performance. Annual monitoring is required to evaluate both the physical and biological performance standards provided in the SONGS permit. Monitoring tracks ecosystem development and identifies adaptive management opportunities pertaining to the physical and biological functioning of the wetland. Independent monitoring is conducted by scientists from UCSB with advice from our science advisory panel. And on the right, you can see the San Dieguito shots of the San Dieguito wetland in 2021. Both east, which is the upper photo, and west of the I-5 freeway. The restored wetland is currently providing habitat for a host of invertebrates, fish, birds, and plants. You can see here. Although the wetland is providing resource values, it has not yet met the performance criteria required for successful mitigation, which will be discussed in the next presentation that reviews the results from performance monitoring in 2021. We'd like to bring your attention to the fact that we have recently revised our UCSB SONGS mitigation monitoring website, and which can be found at the URL indicated above. The website contains useful content on the history of SONGS coastal impacts, on the rationale and requirements for SONGS mitigation, and descriptions of the status of the artificial reef and wetland mitigation projects. Importantly, all of the project's monitoring data are being made publicly available through a data portal of the U.S. National Science Foundation's Environmental Data Initiative, which can be easily accessed through the UCSB SONGS mitigation website. The website has the library indicated for these various reports, and also access to the data portal. The website, which you can see in this slide, the library can be browsed by year, project type, author, and type of document to assist users in finding what they are looking for. Lastly, on the home page of the website, you can subscribe to our mailing list, follow us on Instagram, or contact us by phone or email. That concludes the introduction, and I'd like to turn it over now to Dr. Beheshti.
Thank you, Steve. Okay, so for this presentation, we're reviewing the 10th year of performance monitoring of the San Dieguito Wetlands Restoration Project and our evaluation of the progress of the restoration project in meeting the performance standards required for successful mitigation. So there are two types of performance standards that we're going to focus on today that pertain to the project. The first are absolute performance standards, which are measured only at San Dieguito Wetlands. So an example of this is our habitat area standard, which states that the habitat areas shall not vary by more than 10% from what is outlined in the final restoration plan. The second type of standard are the relative performance standards, and these are standards that are measured at San Dieguito and the reference wetlands. And so these are sites that serve as our natural wetlands that serve as reference sites. And an example of a relative performance standard is that the densities and species richness or number of species of birds shall be similar to that of natural wetlands in the system. So first, we're going to start with the absolute performance standards, which the requirement is that San Dieguito meet each of the 5 absolute performance standards for that year to count towards mitigation credit. And the way that these sets of standards are evaluated is based on the value for that current year. So those 5 absolute performance standards are shown here. So first we have tidal prism, habitat areas, topography, plant reproduction, and exotic species. So tidal prism is the volume of water exchanged in the wetland between high and low tide events. And this is an important metric for measuring tidal flushing, inundation of coastal habitats, and inlet stability. And so for this standard, the permit states that the tidal prism shall be maintained. For habitat area standard, I already overviewed that one. This is a standard that states that the areas of the wetland habitats shall not vary by more than 10% as outlined in the SONGS Coastal Development Permit, in the final restoration plan. And then the topography standard states that the wetland shall not undergo any major topographic degradation, such as excessive erosion or sedimentation. The plant reproduction standard states that a specific set of marsh plant species must demonstrate reproduction, for example, seed set, in one year out of 3, so at least once in 3 years. And then the last standard relates to exotic species. And this standard states that the wetland shall not be impaired, or important functions of the wetland shall not be impaired by exotic species. And this standard is in place because there's a lot of literature to support that exotic species, when they become abundant, can impair important ecological functions and alter food webs or change the physical structure of wetland habitats. So this slide here summarizes the 5 performance standards for each of the 10 years of monitoring. So here, a green dot indicates that the standard was met in that individual year, and a red dot will indicate that the standard was not met. And you can see here that for the last 10 years of monitoring, 4 out of the 5 standards have been met. So these standards are tidal prism, topography, plant reproduction, and exotic species. The habitat area standard, on the other hand, has yet to be met at San Dieguito. And so we're going to spend a bit more time on that specific standard. So the purpose of this particular standard was designed to preserve the mix of habitats outlined in the final restoration plan and guard against habitat conversions like vegetated marsh converting to mudflat or vice versa. And so in the panel shown to the left, this is showing the relative, the location of each of the habitats. So salt marsh is shown in green, mudflat is shown in brown, and subtidal habitat is shown in blue. And the acreages, as outlined in the final restoration plan, are listed below. So now I'm going to walk through how each of these habitats is classified, starting first with subtidal habitat. So habitat is classified as subtidal if it is continuously submerged. Habitat is classified as mudflat if it is intertidal and at or below 3.5 feet NGVD with less than 5% cover vegetation. Habitat is classified as salt marsh if it's intertidal and at or below 4.5 feet NGVD with 30% or more cover of vegetation. And this vegetation cover is evaluated using aerial imagery. And we have an relative performance standard vegetation cover that is evaluated using the same methodology. And then lastly, we have another habitat type classified as other. This is not a planned habitat. It is habitat that is intertidal and at or below 4.5 feet NGVD with less than 30% cover of vegetation. And so this is habitat that is either too sparse to be considered salt marsh or too high to be considered mudflat. Okay, so this figure here on the left shows the planned acres for each of the 3 habitat types, plus or minus that 10% indicated by those red lines there. And so this is the planned acres. Now I'm going to show you the 2021 data. And so as you can see, subtidal habitat area fell within the planned acres. Mudflat at 17.7 acres was 4.7 acres below the minimum required acreage of 22.4 acres. Salt marsh habitat at 74.4 acres was 9 acres below the minimum required acreage of 83.3 acres. And so currently this standard is not met. So next I'm going to look at each of these habitats through time. So starting first with salt marsh, you can see that salt marsh acreage has been steadily increasing since monitoring began in 2012, but we're still slightly below that minimum required acreage. And in 2021, there was a slight decrease in salt marsh acreage. For subtidal, which is just below, the area of subtidal habitat has remained within that 10% for each year of monitoring, with the exception of 2015, which was the year we had this warm water event known as the blob and an El Nino. A consequence of those events was that sea level rise was elevated, and so the acreage of subtidal habitat was higher in that year. Looking now at mudflat, this habitat has started to decrease starting in about 2018 and is now below the minimum required acreage. And then finally, looking at the other habitat here on the bottom right, this is a habitat that has generally been decreasing, but in the last year, we saw a slight increase in. Okay, so moving now onto the relative performance standards. So these are standards that are assessed at San Dieguito and the natural wetlands that serve as reference sites. And so the way that these standards are evaluated is that in any given year, we average the data collected at San Dieguito and the reference sites for that year and the previous 3 years. And this is termed the 4-year running average. And so when evaluating what counts as similar in the context of assessing the performance of San Dieguito, the 4-year running average must be equal to or better than the value for the lowest performing reference wetland for each or for every specific standard. And so to be successful, San Dieguito must provide resource values that are similar to those of the natural wetlands in the region. And so a running average rather than the value for that current year better accounts for natural variation over time, which is inherent in these very dynamic systems. So the Songs Coastal Development Permit, as Steve alluded to, it outlines these criteria for what potential reference wetlands needed to have. So these criteria were that the reference wetlands needed to be relatively undisturbed, tidal, and located within the Southern California Bight. And of 46 sites evaluated within the Bight, the 3 shown on the right were chosen as having best met those criteria. So from north to south, again, this is Carpinteria Salt Marsh, Magoo Lagoon, and Tijuana Estuary. So there are 15 relative performance standards. The first pertains to a physical standard related to water quality. The next 10 relate to biological communities of birds, fish, and invertebrates. And these standards are either density or species richness. For the fish and invertebrate standards, these are evaluated in both tidal creek and main channel habitats. Then we have 3 standards related to vegetation and or algae. And finally, a standard related to food chain support, which is evaluated as the density of feeding birds. So next, I'm going to provide a summary of how these standards have, whether these standards have been met over the past 10 years. And so starting first with water quality. So for water quality, the parameter that we chose to focus on was dissolved oxygen, given its importance to estuarine health. And so the way that this standard is evaluated is we calculate the hours of continuous hypoxia measured as less than 3 milligrams per liter of dissolved oxygen. And those hours of continuous hypoxia are compared at San Dieguito and the reference wetlands. So if the hours of continuous hypoxia at San Dieguito are higher than the reference wetland with the highest number of hours of continuous hypoxia, then San Dieguito would fail to meet that standard. And in the 10 years since monitoring began, San Dieguito has had similar dissolved oxygen, hours of dissolved continuous hypoxia compared to the reference wetlands. And so this standard has been met in all 10 years. Moving now to the biological community standards. In 2021, 6 of these standards were not met. This is the same number of biological community standards that were not met in 2019 and 2020. And these standards are for 2021 were fish density and species richness in main channel and tidal creek habitats, and invertebrate density in main channel and tidal creek habitats. And so the next few slides are going to go through each of these standards that were not met in 2021. But before I go into what the data means, I want to first orient you to the graphs. So here on the left, we have the annual average. So this is for each of the 4 sites. And in the figure on the right, we have the 4-year running average. So for 2021, that is 2021 data and the 3 previous years averaged together. And we've used that green dot, red dot schematic to help guide whether or not these standards were met or not met in the last few years. And so for all of these figures, Carpinteria Salt Marsh is indicated by the blue square. Magoo Lagoon is the down-facing triangle in red. Tijuana Estuary is the yellow diamond, and San Dieguito is the upward-facing triangle in green. And so plotted here is the fish density in the main channel, measured as the number of individuals per meter squared. And so a couple of things to note here. One is that this standard was met until 2020 when it was looking at the 4-year running average, when it was not met. And that is because this decrease in the 4-year running average that was observed at both San Dieguito and Magoo Lagoon was lower at San Dieguito than the decrease we see at Magoo Lagoon. So this standard was not met because fish density is not similar at San Dieguito compared to the lowest performing reference wetland. Looking now at fish species richness in the main channel. So this is measured as the number of species per replicate. So you can see that this standard in 2020 was slightly above the one of the reference wetlands and very close to / overlapping with the lowest performing reference wetlands in 2021. But when we look at the 4-year running average, you see that across all of the reference wetlands starting in 2019, there's been a general decrease in fish species richness. And this decrease at San Dieguito has contributed to more separation between the reference wetland and San Dieguito. And so in 2021, this standard is currently not met, again, because San Dieguito is not similar to the lowest performing reference wetland, which in this case is Tijuana Estuary. Moving now to fish density in tidal creeks. So this standard has been intermittently met over the past 10 years. As you can see from just 2016 to 2021, it was met in 2019 and then again not met in 2020 or 2021. You can see that San Dieguito has, when looking at the annual average, has decreased since about 2016. And this decrease, again, similar to the previous slide, is lower than the lowest performing reference wetland, here being Magoo Lagoon. And so this standard is currently not met. Moving now to fish species richness in tidal creeks. Similar to the previous slide, this standard has been met intermittently over the past 10 years and was met in 2020, but was not met in 2021. And so one thing to note is that you can see that similar to the previous slide as well, there's been this general decrease in fish species richness at all the sites, but that decrease has caused there to be more separation between San Dieguito and Tijuana. And so there's been a general decrease at all sites. And so this standard is currently not met because San Dieguito is not similar to the lowest performing reference wetland, which in this case is Tijuana. Okay, so now we're switching gears to invertebrates. So plotted here on the y-axis is the density of macroinvertebrates measured as the number of individuals per 100 centimeters squared. And so one thing that's important to note for this is that this standard has not been met, as shown here. And the interesting thing, though, even though if you look at the annual average, San Dieguito has been typically most years below the lowest performing reference wetland when looking at the annual average. And then when looking at the 4-year running average, you can see that all the reference wetlands and San Dieguito have seen this increase in the density of invertebrates starting in 2018, but that increase has been less dramatic at San Dieguito, and it has not yet caught up to the lowest performing reference wetlands, which in this case in 2021 were Tijuana and Carpinteria Salt Marsh, sort of overlapping there. So this standard is currently not met. So here we have invertebrate density in tidal creeks. So sort of similar, but a little bit more stark to what we saw with the main channel. You can see that through time, San Dieguito supported lower densities of invertebrates relative to the reference wetlands. You can see this clear separation over time, and that's translated very strongly in the 4-year running average, where San Dieguito is well below the density of invertebrates of the lowest performing reference wetland. And this standard has not been met in the past 10 years at San Dieguito. And so again, in 2021, this standard was not met. So moving now to the standards related to vegetation and algae. So vegetation cover, as I mentioned earlier, is evaluated using aerial imagery. And this standard has not been met in the last 10 years of performance monitoring. The standard for algal cover is also assessed using aerial imagery. And for this standard, we're evaluating, or it was designed to evaluate dense or unusually dense mats of filamentous macroalgae, because this can impair wetland functioning by smothering marsh plants, interfering with foraging birds, and smothering invertebrates. And the decomposing macroalgal mats can negatively impact water quality. And so for this standard, if the algal cover in San Dieguito is higher than the reference wetland with the highest algal cover, then San Dieguito would fail to meet this standard. But in the 10 years of monitoring, it has met this standard in every year. And lastly, we have Spartina canopy architecture. So this is a standard that measures the proportion of stems of Spartina foliosa that are over 3 feet tall. And the reason that this standard is important is because Spartina that is over 3 feet tall is required nesting habitat for the endangered ridgeway rail. And so this standard currently is only assessed at San Dieguito and Tijuana River estuary. And if the proportion of stems that are 3 feet or taller is equal to or above that of the reference wetland, then this standard would be met. And so this standard has been met since 2013. So similar to before, I'm going to focus on the standard that was not met in 2021, which is vegetation cover. So you can see that vegetation cover has been steadily increasing at San Dieguito, but it has not yet reached the levels we see at the reference wetlands, and is still well below the lowest performing reference wetland, which is Carpinteria Salt Marsh. And so this standard was not met, but Dr. Mark Page will be speaking about the experiments that we are currently undergoing to inform Southern California Edison's planting program. And then after that talk, Dr. Sital Prabhu will overview the planting program itself. And so you'll get a little bit more background on how we are managing to hopefully bring this particular standard up to the levels we see in the reference wetlands. And finally, we have food chain support. So as I said earlier, this is measured as the density of feeding birds. And so you can see that one thing that's clear is that Mugu Lagoon has been the highest in terms of the density of feeding birds over the entire time series. And that starting in 2016, the 4-year running average has fallen below the reference wetland, specifically the lowest performing reference wetland, Carpinteria Salt Marsh. And so this standard has not been met at San Dieguito since 2016. So to review, San Dieguito must meet at least the same proportion of relative performance standards as the lowest performing reference wetland in a given year for that year to count towards mitigation credit. And so the way that this is evaluated is across all 4 sites, the proportion of relative performance standards met are calculated and compared. And the rationale behind this is that requiring San Dieguito to meet at least the same proportion of relative standards as the lowest performing reference wetland, it meets the intended goal of having a restoration site that is similar to the natural wetlands without requiring San Dieguito to outperform the natural wetlands. And so shown here is the summary of the 2021 data. So the green dot indicates that a particular standard in that wetland was met and is similar to the other wetlands. And a red dot means that the standard was not met. And then a gray dot means that that standard is not assessed in that particular wetland. And so for Carpinteria Salt Marsh, we see that they met all of the standards. Magoo Lagoon met all but one standard. Tijuana Estuary met all but 3 standards. They did not meet the water quality standard, invertebrate species richness in main channel, or Spartina canopy architecture. And then San Dieguito met 7 out of the 15, or 47% of the standards. And so to review, since San Dieguito must meet at least the same proportion of relative performance standards as the lowest performing reference wetland, which in this case is Tijuana, this requirement was not met because San Dieguito met 47% and Tijuana met 80%. And so this slide reviews the mitigation credit for the San Dieguito's wetland restoration project. So like I just said, in 2021, San Dieguito did not meet the relative performance standards requirement because it did not meet the same proportion of standards as the lowest performing reference wetland. And as I mentioned earlier in the talk, San Dieguito must meet each of the 5 absolute standards to be able to receive mitigation credit and failed to meet the habitat area standard. And so as of 2021, San Dieguito has earned 0 years of credit and needs still the remaining 32 years of mitigation credit. And so to end really quickly, so there's this graph here is showing the proportion of standards passed through time at all of the sites. And you can see that there has been this underperformance of San Dieguito that is driven in large part by the standards that we chose to focus on today. And so we are beginning to evaluate potential remediation options, but are in the phase where we must first investigate and better understand the reasons why these standards are underperforming before we can make any recommendations. And so in Dr. Mark Page's talk, he's going to be focusing on the investigations that MSI has led to help inform potential remedial actions and or adaptive management options. And so we're going to focus now on the vegetation cover and salt marsh habitat area standard and the invertebrate density and species richness standards, all of which are underperforming as of 2021. And so with that, I will pass it on to Dr. Mark Page.
Thanks, Kat. Well, this presentation concerns the status of standards that have consistently underperformed in San Dieguito wetlands, and a review of some of the data that we've been collecting to understand and address the reasons for this underperformance. What's going on? Well, standards that have consistently underperformed over multiple years in San Dieguito wetlands include 2 that depend on the development of salt marsh vegetation. The first is the habitat area standard, which as an absolute standard must be met every year. This is the only absolute standard that has yet to be met. The second standard is the relative standard for vegetation cover, which also has not yet been met. Because of the importance of vegetation development to meeting these 2 standards, a discussion and adaptive management activities to increase vegetation cover over the past several years has been a focus of efforts by ourselves and SCE. Among the standards that pertain to biological communities, which have consistently underperformed, are those related to the densities of invertebrates in main channel and tidal creek habitats. That standard for invertebrate density in main channel habitat has only been met once in 10 years. And the standard for invertebrate density in tidal creek habitats has never been met. The second group of standards have underperformed more recently, and these include the relative standards for fish density and richness in main channel and tidal creek habitats. These standards have not been consistently met in the last 10 years, and none of these standards were met in 2021. Another standard pertaining to food chain support in terms of the density of feeding birds has also not been met in the last 5 years. For today's presentation, we will discuss the current status of vegetation and the results of 2 experiments undertaken to evaluate factors that could improve the success of the SCE planting program. We will also present some analyses and observations pertaining to possible factors that might be contributing to the low densities of invertebrates. Since invertebrates are important in food chain support to fish and birds, these mechanisms may also apply, at least in part, in explaining the underperformance of those standards. Well, there are 2 standards that pertain to the cover of vegetation. Again, the first is the habitat area standard. And this is an absolute standard that is evaluated only in San Dieguito wetlands and specifies that the area of the different habitats shall not vary by more than 10% from areas in the final restoration plan. To be classified as salt marsh habitat, the cover of vegetation must be at least 30%. And this 30% is evaluated within 10 by 10 meter grids, covering the entire wetland, as discussed by Kat in the performance talk. The second standard that pertains to the cover of vegetation is the vegetation standard. And this standard requires that the proportion of total vegetation cover in the marsh shall be similar to those proportions found in the reference sites. In practice, the standard is only evaluated in habitat that has been classified as salt marsh, that is at least 30% cover. Well, this slide reviews the change in area as acres of salt marsh habitat over time. The planned acres of salt marsh habitat is shown by the red line, with plus or minus 10% of that value indicated by the dashed black line. Although progress has been made in vegetation development, as shown by the images on the right, the wetland remains about 9 acres short of the minimum required number of acres of salt marsh. That is at least 80%, or at least 30% cover of vegetation. There was an appreciable increase in the acreage of salt marsh habitat from 2018 to 2020, likely facilitated by the higher levels of rainfall during 2018 relative to previous years. But then there was a slowing in 2020 and a small decline, a little over 3 acres from 2020 to 2021, perhaps a result of the low rainfall that we've received over the past couple of years. Well, one goal of the restoration project is to achieve not only the minimum of 83.3 acres of salt marsh habitat, but a high cover of vegetation similar to the reference wetlands shown along the bottom of the slide. The photos on the left show the high cover of Spartina, cordgrass, found throughout lower marsh plain elevations in San Dieguito wetlands. But the cover of vegetation, which consists largely of Salicornia, pickleweed, at higher elevations is more patchy. Taking a look at the trend of overall increase in vegetation cover, the figure on the right shows changes in vegetation cover over time for cover classes of vegetation from greater than 85%, from 60 to 85%, and 30 to 60% through 2021. There was an appreciable increase in the acres of greater than 85% cover to around 30 acres in 2019, and that increased to close to 35 acres in 2020, but then has declined in 2021. The acres in the 60 to 85% cover class bin also declined. The cover in the 30 to 60% cover class has changed little over the past couple of years. This likely reflects a slowing of growth vegetation out of the cover classes of less than 30% and into this 60 to 85% class, and of the 30 to 60% class growing into the 85% cover class. The inset on the right then shows again the overall progress of increasing areas of at least 30% cover through 2021. That is, we want to achieve 83.3 acres, and we currently stand, as Kat mentioned, at about 74.4 acres. Well, cordgrass, Spartina foliosa, continues to expand in distribution throughout the lower elevation areas of the restoration project. And this aerial image shows cordgrass patches indicated by the yellow color in modules W4, W16, and W5 on the east side of the freeway, and around the basin module W1 and W2, W3 on the west side of the freeway. And you can see that there was an increase of about 4 to 5 acres from 2020 to 2021. Cordgrass has expanded into shallow areas of some of the tidal creeks in modules on both sides of the freeway. And you can see little specks of yellow, for example, in module W2, W3 in the upper right hand image. And we'll touch again on this further in the presentation. Well, to address the shortfall in acres of salt marsh habitat and to increase the cover of salt marsh vegetation, SAE is conducting a vigorous planting program, which Dr. Sital Prabhu will talk about in the presentation following this one. 2 experiments were embedded within the planting program back in 2020. The goal of the first experiment, which we call the Idops experiment, was to test the effect of several variables to increase plant cover in sparsely vegetated areas at higher elevations. These variables were irrigation, soil decompaction, soil amendments, the planting of potted plants, and seeding. Only one plant species was planted as part of this experiment, and that is the Paris's glasswort or Throcnum subterminale, which is typically found at higher tidal elevations. We call the second experiment the fill-in experiment. And the goal of the fill-in experiment was to test the effect of planting and plant species versus seeding on filling in gaps in plant cover at lower elevations. There were no soil treatments or irrigation in this fill-in experiment. 3 plant species were evaluated, shown along the bottom. Again, pickleweed, Salicornia, alkali heath, Frankinia salina, and Paris's glasswort, or Throcnum subterminale. These were planted and compared to a seed-only mixed treatment in an unmanipulated control. Well, this slide shows the location indicated by the star and layout of the 2 experiments. That is the Idops experiment number 1 there, which is located at higher elevations along a berm, and you can see the road along the top of the berm there. This experiment was done in modules W4, W16 on the east side of the freeway. Also included here is the fill-in experiment, which was located at lower elevations. And we have another fill-in experiment also on the west side of the freeway in modules W2. These experiments were started, as I mentioned, back in 2020. In this case, it was early March. And the experiments were concluded in mid-January of 2022. We collected data on the percent cover, growth, and survival of plants in the experimental plots. So the next few slides will just summarize the results of these experiments. To summarize the results from the seed mix experiments, the difference in mean plant cover between seeded and control plots was less than 5% and not statistically different for both the Idops and fill-in experiments after over 22 months. That is, in a nutshell, there is no effect of seeding on plant cover. This slide summarizes the results for the percent cover of our Throcnum after 22 months. This was the planted species. The 2 panels on the left show the percent cover in unplanted treatments, that is not planted, that were either not irrigated, so the upper left figure, or irrigated, the lower left figure, in plots that were either decompacted or amended, So we use D to designate decompacted, and A designates amended. So D minus A minus received neither of those treatments. Decompacted but not amended, so D plus A minus, or decompacted and amended, receiving both those treatments, D plus A plus. The two panels on the right show the percent cover in the planted treatments. That is the treatments that were planted with orthoctonum that were either not irrigated, so the upper right-hand figures, or irrigated, again, the lower right-hand figure, and plots that received one of the three soil treatments. The black dashed line at 30% cover represents the target minimum cover required to be classified as salt marsh in performance monitoring. And we can see that planting, that is the panels on the right, increase the cover of orthoctonum relative to non-planted controls on the left, but only by up to around 10% or so. Looking at the right two panels, statistical analyses, the details of which are not presented here, also showed that neither irrigation or the soil treatments affected the percent cover of orthoctonum. Well, an unexpected result of our experiment was the recruitment of pickleweed, Salicornia, into some experimental plots, as shown here. So this slide shows the percent cover of all vegetation. That is the planted orthoctonum, the non-planted Salicornia, together with a small contribution of other species, which was largely Frankinia, in the experimental plots after 22 months. The panels are arranged in the same order as in the previous slide. And we can see that planting and or irrigation, that is the panels on the right or along the bottom, the irrigated treatments, combined with soil treatments, increase the cover relative to controls, that is not planted, D minus A not minus, no decompaction, no amendment, with a substantial contribution from the non-planted Salicornia indicated by the green in plots that had been irrigated and received the soil treatments along the bottom, the panels along the bottom. However, the bottom line from this experiment is that the 30% cover target was not reached even after 22 months in any treatment. Well, this slide summarizes the results of the fill-in experiments that were conducted at lower elevations at two locations without irrigation or the soil treatments. Again, three species were planted: Salicornia, Frankinia, and orthoctonum. We can see that planting increased cover relative to the control, that is the no planting, for the Salicornia treatments after 22 months at both sites, with the 30% target obtained in that Salicornia treatment. Salicornia performed as well or better than Frankinia, which performed as well or better than orthoctonum. It varied between the two modules. So to summarize, seeding did not increase vegetation cover relative to controls at project elevations in either the Idops or the fill-in experiments. In the Idops experiment, planting orthoctonum resulted in a small increase in cover relative to non-planted controls. However, none of the Idops plots achieved the 30% cover target after 22 months. Decompaction and irrigation encouraged or seemed to encourage the recruitment and growth of Salicornia. And in the fill-in experiment, planting increased average cover of Salicornia and Frankinia at both sites, up to and exceeding the 30% target relative to the control, which is no planting. So to summarize recommendations or lessons learned from the Idops and fill-in experiments, seeding as implemented in the Idops and fill-in experiments is not recommended to increase cover at project elevations. Planting orthoctonum while contributing to a more diverse plant community is not recommended if a rapid increase in percent cover is desired. Planting of Salicornia and Frankinia in vegetation gaps at lower elevations is recommended as an effective approach to increase vegetation cover, supporting previous recommendations. Well, this slide will provide some recommendations to meet the required area of salt marsh habitat and the relative standard for vegetation cover as it relates to elevation. Again, just to review the absolute standard for habitat areas, the requirement is a minimum of 83.3 acres of salt marsh habitat, that is with at least 30% cover in San Dieguito Wetlands. The current deficit right now is about 9 acres of salt marsh habitat. So the recommendation is to plant in vegetation gaps at lower elevations to increase cover to at least 30%. And there's about 20 acres of other, quote, habitat located lower, which is less than 30%. So there's plenty of acres down there to implement this. Again, reviewing the standard for vegetation cover, the requirement is that salt marsh cover in San Dieguito Wetlands must be similar to the lowest performing reference wetlands, which is around 85%, a bit lower right now, but this is sort of a target value. The current percent cover in San Dieguito is about 74%. That's the 4-year running average. So again, there are about 20 acres of other available lower. Therefore, successful infill planting lower will not only eliminate the deficit in salt marsh habitat, but is also recommended to achieve the desired about 85% cover of vegetation in salt marsh habitat. Well, turning now to the underperformance of invertebrates in San Dieguito Wetlands. Just to review that the requirement is that the total densities and numbers of species of macroinvertebrates shall be similar to the densities and numbers of species in similar habitats in the reference wetlands. And this relative standard is evaluated separately in 2 habitats, main channel and tidal creek. Well, to review again, the standards for invertebrate density were only met the first year in main channel habitat and have never been met in tidal creek habitat. The standards for species richness in main channel habitat and tidal creek have been more consistently met, although the standard was not met in tidal creek habitat in 2019 and 2020. Most of the invertebrates that are sampled consist of small infauna, particularly different types of worms illustrated in the images on the right. So there may be different or more than one explanation or mechanism contributing to the underperformance of invertebrate density in tidal creek and main channel habitats. 2 hypotheses are currently being evaluated pertaining to the underperformance in the density of invertebrates in San Dieguito relative to the reference sites. The topography hypothesis proposes that an aspect or aspects of the physical structure of San Dieguito wetlands is contributing to the deficit of invertebrates. As mentioned earlier, a Spartina has encroached into the bottoms of tidal creeks in some locations, suggesting that tidal creeks are more shallow than in the reference sites, and this could affect invertebrate abundance in this habitat. The second hypothesis that we are evaluating concerns sediment properties. Sediment properties, for example, the percent of silt clay or the amount of organic content in the sediments has been shown to influence invertebrate distribution and abundance in some wetlands. We have observed that sediments at some main channel sites in San Dieguito, for example, appear sandy, but we lack information on how grain size or organic matter content might vary among our study wetlands and habitats. Our approach to evaluating these 2 possibilities is to use data on invertebrate density that was collected during annual performance monitoring in 2020 and 2021, together with ancillary data on sample elevation of the collected samples. During performance monitoring in 2021, we also collected sediment samples from a subset of our sampling locations and had these samples analyzed for grain size characteristics and percent organic matter content. Today, we will present some data on the relationship between invertebrate densities and elevation. We have recently received the results of the sediment analysis, and these data are currently being analyzed. Well, last year, we reported that the elevations of the tidal creeks in San Dieguito wetlands are higher than in the reference wetlands. So in the figure on the left, we include data that were collected in 2021 and provide more data on where these differences occur. Each point in the figure represents an elevation measurement taken at the location of each of the cores that we take to sample the small and small and final invertebrates. The darker horizontal bars are median elevations. The boxes represent enclosed 50% of the data, and the vertical lines encompass the range of values. You'll notice that the median elevation in San Dieguito is about 0.8 of a foot higher than the reference wetlands, but also that sample elevations are lower, extend lower, about 1 to 2 feet in the reference sites as compared to San Dieguito. Taking a look at the relationship between invertebrate density and elevation, this figure shows invertebrate density as the number of individuals per 100 square centimeters on the y-axis and elevation on the x-axis. For reference wetlands, Mugu Lagoon and Carpentry Salt Marsh as the gray symbols, the gray circles, and San Dieguito wetlands as the green triangles. You will notice that, as illustrated in the earlier slide, the elevations for Mugu Lagoon and Carpentry Salt Marsh extend lower than those at San Dieguito wetlands, which has few points below about 0 feet NGVD. The data for Mugu and Carpinteria are not statistically different and are combined in the regression line for these sites. The black line shown here uses the combined data. There was a significant negative relationship between density and elevation for Mugu and Carpinteria and San Dieguito wetlands. The slide includes data for Tijuana estuary, shown on the right. There was no relationship between invertebrate density and elevation in this wetland. Tijuana estuary differs from Mugu Lagoon and Carpentry Salt Marsh in that there are few tidal creek sample points below about -1. Taking a look at main channel habitat, the figure on the left shows elevation data for the sampled sections of section from this habitat. The median main channel elevations of San Dieguito wetlands are within the range of the reference sites. This figure shows the relationship between density and elevation main channel habitat in San Dieguito wetlands and Mugu Lagoon and Carpentry Salt Marsh. As reported last year, there was no relationship between elevation and invertebrate density in main channels at San Dieguito wetlands. There was a negative relationship between density and elevation for Mugu and Carpinteria, and this relationship differed between the two sites. Similar to the tidal creeks, there was no relationship between density and elevation in Tijuana estuary main channel habitat. Well, to summarize, the elevations of tidal creeks and San Dieguito wetlands do not extend as low as the reference sites. The negative relationships between invertebrate density and elevation in San Dieguito, Mugu, and Carpentry tidal creeks, and the lack of a relationship in Tijuana suggest that higher elevations in San Dieguito could explain, at least in part, lower densities of invertebrates at San Dieguito in this habitat. Main channel elevations are within the range of the reference sites. However, the lack of relationship between invertebrate density and elevation and main channel habitat suggests that other factors, for example, sediment properties or something else, influence invertebrate densities in this habitat. Well, moving forward, to continue to try to understand the mechanisms that are leading to the underperformance of invertebrates in main channel and tidal creek habitat, we'll continue to analyze existing data. I mentioned we've collected these sediment samples. We will be examining relationships between sediment properties and invertebrate density in both tidal creek and main channel habitat in San Dieguito wetlands and in the reference wetlands. We'll also collect and analyze new data, taking advantage of some deeper tidal creeks that are located in the nearby 6-year-old 22nd Ag District restoration Sample these during 2022 performance monitoring. In this image, you can clearly see that the Ag District tidal creeks, located just across the river channel from module W2, W3 in San Dieguito Wetlands, are filled with water in comparison to the empty San Dieguito creeks on the other side of the river channel. The expectation is that invertebrate densities will be higher in the Ag District creeks if elevation is contributing to differences in invertebrate densities that we see among wetlands. So I'd like to just conclude with the figure that Kat presented during her presentation and reiterate that we are beginning to think about, evaluate potential remediation options, but we're still trying to understand the reasons why the wetland is not meeting certain performance standards that will help inform our evaluation of these remediation options. So with that, I will conclude and turn it over to Tidal, who will discuss SE's planting program.
Thank you, Mark. Hopefully my screen share works.
Yep.
Perfect, thank you. Good afternoon, everyone. My name is Tidal Prabhu. I work in the Environmental Services Department at Southern California Edison, and I'm the project manager for this awesome project, the San Dieguito Wetlands Restoration Project. Today, I'll be speaking on the recent activities undertaken by Edison at the wetlands. I'll start with our strategy and approach, follow it with the implementation of those strategies, and end with a summary and next step slide. Starting with our approach here. So as you would have heard in the previous two talks, to get mitigation credit, the wetlands needs to meet the absolute performance standards for the habitat area, as explained by both Drs. Page and Beheshti. The wetlands has consistently not met the habitat area standard. So when we decided to undertake remedial activities, mainly planting, at the wetlands, we needed about 45 acres of salt marsh habitat to meet that habitat area standard. So our goal is to meet the habitat area standard by increasing the area of salt marsh habitat. So our approach to achieving this is kind of two steps. First is to determine how many acres are required and which locations need or can receive these remedial actions. To do this, we analyze the aerial data that's collected by MSI, and we pair it with field visits or field assessments. And field assessments are pretty critical in our planning because the aerial data is often collected in late spring or early summer, and by the time we're ready to plant, which is the following winter, things evolve in the field. So we use both sets of data to make our plan for the year. Following this analysis, we prioritize based on level of effort and elevation. And I mentioned elevation because our prioritization in the first few years, which is 2018 through 2020, was on the higher elevation or the high marsh areas, which are greater than 3.5 feet NGDD. And we chose to focus on the high marsh because we knew that this would take the most amount of time to establish cover, and we wanted to get it on the path to success before addressing the lower elevations. And based on the results that we've seen since then of the aerial data each year, and also having gotten those upper marsh areas trending towards increasing cover, and on the advice, as Mark mentioned earlier in his talk, on the advice from MSI or Marine Science Institute, our focus has shifted to areas within lower elevations or less than 3.5 feet NGDD as of 2021. And additionally, we've also now begun planting in areas that we hadn't planted in before. Throughout our decision making, we've collaborated with the Commission, the Scientific Advisory Panel, and MSI to sync up with our approach and objectives. And this has included undertaking experiments and adapting our approach as needed. An example was the observation that gallon potted plants tend to do better at San Dieguito than rose potted plants. So based on that, our plant orders since then have been gallon plants from the nursery. An added factor influencing my decision-making here at Edison is the cost of undertaking the remedial activities. I have a set annual budget for the project, and it plays a major role in how much we can undertake in the field and how we prioritize the activities for the year. So this shows our work areas or areas that we've worked in or applied remedial activities or actions since 2018. Remedial activities include planting, seeding, applying soil amendments, installing an irrigation system, mainly to assist with survivorship and establishment of plants in the upper elevations. And today I'm going to focus on planting since that is the predominant action we've undertaken since 2018. In fact, as you can see in the table there, we've planted a total of 209,000 plants. In early 2021, we planted about 51,000 plants, and then I presented at the workshop. And following that, and this was after aerial data was collected by MSI, we have planted about 73,000 plants in late 2021 and early 2022. And I like showing this picture. This is a picture from our 2022 planting, and it kind of shows the ground view on the left and the aerial view of the planting on the right. And hopefully you can see the little dots on the right image here. Those are the pots of plants. And thank you to MSI for providing the drone image. And on the left is what I'm used to, which is what it looks like on the ground. And hopefully both of these perspectives, is pretty clear to the audience here, and they're both important because the aerial perspective is how the project is monitored and assessed for habitat area, and the ground perspective is important to see, what's happening and how we undertake our remedial actions. And here's a list of the plant species that we've installed at the project over the past 4 years. It's pretty diverse, and I've also added some photos of some of the species that we've observed at the wetlands. Our top species is Salicornia, with about 71,000 plants that have been planted thus far. And again, we've installed about 209,000 plants since 2018. I'm going to share a couple of time series in areas that we've planted in, and I'm going to start with this area here, starting with what it looked like prior to planting. You can kind of see the bare areas, if you will, that is just open for plants. This is an image immediately after planting, both from 2019. And here's an image from 2022 April. And you can see hopefully the vast improvement in cover since the action of planting. Here's another location within the wetlands. This is what it looked like before planting. Here's what it looks like immediately after planting. And this is what it looks like today, well, April of 2022. So in this case, you can see, yes, there's been an improvement in cover, but there are still open spots where we can definitely install more plants and get it trending towards that salt marsh cover criteria. And one more sort of time series here. This is more recent. This is an area that was planted in early 2021, February, March of 2021. I don't have a photo of before planting. And this is what that site looks like in 2022. Since it's only been a year, it doesn't seem like there's a marked difference, but it does show that these plants are surviving, and we hope that it will soon take off and grow. Some photos from around the wetlands of the plants. So on the top left is a Jalmea that we had planted in 2019, I think, and now it's happy and established and sending runners out, which is great to see. We've also seen Limonium recruitment, and another fun observation was observing fiddler crab activity near a newly planted Disticulus. On the bottom right is a picture of our fall 2021 planting. It just is indicative of the density at which we are planting, which is about 1.5 feet to 2 feet around center. And on the bottom left is a naturally occurring triglocken in bloom in the wetlands. I thought it was a pretty cool photo to share with the audience today. So in summary, here's a plot. It should look pretty familiar based on the previous two talks. So just to explain it again, this shows the change in salt marsh habitat area since we have undertaken remedial actions. 83.34 is the minimum target, so it's the minus 10% of the 92.6 goal that we have to achieve per the final restoration plan. The x-axis is the year that the data was collected, and the y-axis is the area in acres. So you can see, as Mark mentioned, we are still 9 acres away from meeting the target. And in 2020, the difference, and we did see a little bit of a decrease from 2020 through 2021, about a loss of 3 acres, 3.5 acres. But I have to say, with what we're observing on the ground and the time series photos that I've shown you today, and the fact that we planted about 73,000 plants after the data was collected, I'm optimistic that we will go back to seeing an upward trend in salt marsh area increase in the upcoming years. Again, in summary, the remedial activities thus far have focused on the goal of achieving the salt marsh area to meet the absolute standard for habitat areas. The approach and strategy is based on the monitoring data that's provided by MSI and also real-time field conditions and budget availability. And we'll continue with this approach until we meet the absolute standard. In addition, we'll continue to plant anyway, because increasing the vegetation cover helps to meet the relative standard as well. And that's my rinse and repeat bullet there. And finally, I want to reiterate that all of this is undertaken with advice, consensus, and collaboration from our agency partners. And I look forward to continuing to collaborate not only on this planting approach, but also on any other remedial activities that might help the project achieve the overarching permit conditions. So with that, thank you for the opportunity to speak today, and I will hand it back to Dr. Coteen.
Thank you, Steve, Kat, Mark, and Satal, for another really informative presentation. We're now ready to take questions from the webinar attendees. If you have a question, feel free to either type it into the Zoom chat box or raise your hand and I will call on you. I see a question in the chat box from Kirsten Wasson. And the question is, do you know how marsh community composition compares to your reference sites, comparing similar elevation zones for apples to apples comparisons?
Not sure what the question is. I mean,
I think I can try to take that.
okay.
We really haven't done that comparison yet. We could. I suspect overall that the diversity is going to be less at San Dieguito at present. I mean, because, but it likely will increase. I think in all the 210,000 plants that Satal's group has planted, there is a mix of species, but
Oh yeah, so that definitely is the case. Right now, there's not the vegetation diversity compared to, say, Magoo Lagoon or
Yeah,
the upper
Tijuana.
areas of Carpinteria or Tijuana. So
Yeah.
that's for sure.
I mean, one thing that is missing, which is good, is the invasive limonium species.
But the standard for vegetation is vegetation. The relative standard is vegetation cover.
Right.
There isn't a richness aspect to that.
Yeah, that was going to be my point. I mean, there's not a permit requirement to have similar composition, and so we don't actually measure community composition, plant community composition, as part of the monitoring for this project. So I mean, we could speculate about how it compares based on our observations there, but it's not part of the formal monitoring program because it's not a performance standard.
And I don't think we can pull that out of our aerial imagery, which is what we use to assess percent cover. It would be nice, but it's probably not possible.
Do we have any more questions from the group? Or I don't see any in the Q&A.
So Lori, I believe there's about 8 questions in the Q&A. At least
I can see 8 questions.
So I see 8 questions as well, and they were answered.
Yeah.
Okay.
Would you like
Yeah.
me to read the questions and the answers, or how would you like to proceed?
I think everybody who's in attendance can read the questions and the answers. So
Yeah.
I guess if anybody's interested in a follow-up, we could talk about that, but otherwise it doesn't seem like we need to have them read now.
Okay.
There was a question about similar levels of drought and water pollution, I guess, in the wetlands, in the reference wetlands. We did the best. There are no relatively, we picked relatively undisturbed wetlands as reference sites, but relative, we all know that the wetlands have been disturbed to some extent. Each one has its own particular issues. We know about Tijuana Estuary and the inputs it gets from the Tijuana River occasionally. Carpinteria Salt Marsh is located right next to, the Carpinteria Valley is developed for, well, now it's cannabis, but it was cut flowers, and has received nutrient inputs in the past. And Magoo Lagoon, I suspect during rainfall events in particular, gets inputs of nitrogen and other materials during runoff events. And so they all to some extent have those sorts of issues, and they might be most pronounced during rainfall or runoff events. That's about all we can say about it at this point.
Yeah, maybe it's also worth commenting that, each of the watersheds draining into the estuary have their own unique characteristics and sizes too. So I think the point of getting a range of reference wetlands is to have a range of conditions that are characteristic of Southern California, so that we could judge this wetland to see if it was functioning similarly to this range of conditions. And so I would say that, yes, there are differences in water pollution and differences in responses to drought based on differences in watersheds and whether there's a dam upstream or not. But the idea is that there's this range, and so we're trying to capture that range. But there's no way to make them similar, because every watershed and every coastal wetland is unique in its own way in this coast.
But related to that is that some of the relative standards do, they kind of address that issue. For example, we're measuring the abundance of green macroalgae, which could reflect excessive nutrient input. We're measuring dissolved oxygen concentration, which could reflect, accumulation of organic matter or reductions in tidal flushing. So we do measure some attributes that might reflect water pollution or poor water quality.
Are there any more questions for our panelists? I'm not seeing any more questions. Please don't be shy. Okay, we have a thank you. Thank you for the presentations, panelists. Okay, well, seeing no more questions, I'll say thank you very much for all our attendees and for our panelists, and we're going to end the webinar now. Thanks so much for coming.